And now we're going to hear from Team Healthy Breathing.
Good evening. Over the course of 48 hours, we've designed a breath analysis device named MediBreathe. My name is Jessica Guardado, a sophomore mechanical engineering student at Texas A&M.
Hello, my name is Juan Rodriguez, mechanical engineering major in Texas A&M. I'm also a sophomore.
Hi, I'm Gisela Rodriguez. I'm a sophomore biomedical engineering major at Texas A&M.
Howdy, my name is Luria. I'm also a sophomore mechanical engineer here at Texas A&M.
Hi, I'm Akash. I am a senior in mechanical engineering at IIT Tirupati.
Hello, my name is Ravi Srivatsan. I'm senior mechanical engineering at IIT Tirupati.
Hello, I'm Aditya. I'm a senior mechanical engineer from IIIT.
So we're going to go ahead and introduce our device with a video clip. Did you know that 1 out of 10 children have asthma? And that asthma costs hospitals 60% of ER visits. Current methods for asthma detection are expensive, restrictive, and require medical training. Accurate, portable, affordable, the MediBreathe. The MediBreathe is a user-friendly, state-of-the-art asthma diagnosis device. So easy, a doctor can use it, a nurse can use it, and a parent can use it. Helping you and your family breathe in peace. The MediBreathe. So as we all may know, asthma is a common respiratory disease, one of the most common. 339 million people worldwide have been diagnosed with asthma, and there's been a report of 4,000 deaths in the United States alone yearly. 6.2 million children have been diagnosed with asthma in the US only, and is the third ranking cause of hospitalization of children under 15. Now, these are only the numbers that we know. The problem that we will be tackling is the underdiagnosis of asthma. The underdiagnosis of asthma has caused thousands of preventable deaths.
Currently, the traditional methods of diagnosing asthma are very costly, and as a result, many parents do not want to invest the time, energy, and money that it costs to go and make a hospital visit. Doctors tend to rely more on self-reporting of symptoms for asthma, which causes a lot of misdiagnosis, especially in children who cannot accurately express their symptoms. In fact, anywhere from 20 to 70% of people are living with undiagnosed asthma. In order to combat the issues that these traditional methods have, we wanted to make a device that was portable, affordable, and accurate. We also wanted it to be small enough that it could be transportable so that it could be used within schools or in medical refugee camps. We also wanted it to be sterilizable so that it could be used for multiple patients in a short amount of time. And we wanted it to be easy enough to use that someone with no medical training would be able to administer the test.
So our solution, again, it's called the MediBreathe. It is very simple, it's non-invasive breath analyzer. It is can you go to the next slide? It is basically composed of two chambers, the gas chamber and the analysis chamber. In the gas chamber, that's where the sensors will be found, and then in the analytics chamber, that's where the brains of the system will be found. Now my friend Akash is going to demonstrate how the sensor would work. We really wanted it to be a low-cost solution to this problem, because this problem is found in many areas of the world. So in our model that we made today, Akash actually needs to go to the hospital, but it has 5 LEDs which are different colors to designate different levels of asthma severeness.
So how does it work? As we all know, when we breathe gas out, so it's actually composing of more than 1,000 volatile organic compounds. What are these? These are nothing more than metabolites, which are produced in our body. So analyzing these metabolites give us a real-time data of how is our body processing. So by this, we will be able to detect diseases at an early stage, which will help us in which will help us in analyzing them, and also we can even use it for giving the right drugs to the right people who need it. So when we went through the literature, we found that the bioindicators at the left were the important biomarkers for asthma. So we were the sensors which are in the right, we are using those sensors to indicate that the person has asthma or not.
So let me walk you through how it works. So the first is we concentrate the gas and we isolate it so that it's not contaminated by the external environmental air. So to do that, the gas actually passes through a particulate matter filter and a hygroscopic filter to remove any humidity. And it enters the sample gas chamber where we have a sensor array consisting of the aforementioned sensors which respond to the gases. And these signals are sent to an onboard microcontroller. So this microcontroller runs a smart algorithm that can tell you if you've got asthma or not. And not just tell you if you've got asthma or not, and if you do, it can even tell you what grade of asthma you've got, as in mild, moderate, intermediate, or severe. So what makes us different? So if you recall, I said smart algorithm. So that's what makes us different. Traditional and present methods of asthma detection usually rely on one biomarker or maybe two, and an expert's opinion, which could always be subjective. So, and what we're doing is we're measuring 8 different biomarkers, which are the features or inputs to our random forest classification algorithm, which can detect, when trained with the appropriate data, if you have asthma or not, and what class. So in that case, you would also you would get over misdiagnosis of asthma. And for example, all of us was the girl in the video. She got immediate medical response. So what if there was a girl in a remote village who's not able to? In such cases, and what if there was no trained medical professional who could administer the right medical interventional treatment? They don't know what to do, whether it's an inhaler or bronchodilator or an EpiPen. So with MediBreathe, it can tell you what grade of asthma you've got, and you'll know if you just need an inhaler or you might want to go to an EpiPen.
So we were given a problem and we have delivered the solution. But what follows afterwards? Now, since they explained there's different biomarkers for different diseases. Now, if we were to change the data that we have and the sensors that we put inside the box, we can detect different diseases such as lung cancer, diabetes, and even traumas, just to name a few. Now, in the video, we said we wanted to work with a lot of people who may know about, who may be trained in medicine, or who may not be. Parents, educators, and we want to extend it even to first responders, because you never know what you may find on the scene, and even non-governmental organizations. We want to help anybody that we can, and we want to help advance the field of breath analysis with this type of research and continue to develop into a better technology.
So thank you. And any questions?
Judges, you have 5 minutes to question the team.
Are you in this device only for asthma, or you're envisioning for multiple other disease processes?
Yeah, so the lung is basically a gold mine. It's something, so everybody breathes out, right, exhales, hopefully. But so since it is something that you like normally do, and it's not very you have to prick at it. A lot of diseases do have to not only for example diabetes, it has nothing really to do with the lungs, but there is an effect that happens obviously in the blood that makes a reaction happen in the lungs. And then these biomarkers, there's several for diabetes. Acetone would be the one for diabetes. But yeah, the purpose is not only to do asthma, but to expand it to as many diseases that have biomarkers in the lungs.
Some of the biomarkers which we have chosen for asthma are also common with other diseases. So based on the concentration level, we can indicate that which disease.
I mean, if we had a right training data, we could also train the model to identify maybe lung cancer, which has almost as many biomarkers with almost the same biomarkers, and a little more, but maybe, I mean, we can get there.
So in the beginning, you mentioned about sterilization. How do you plan to do that? And another question is, how do you make sure that the residuals from a previous reading are not affecting your current reading?
Sure. So the mouthpiece right here, I mean, yeah, this is just an alpha prototype, but the mouthpiece is disposable, and so different people can get different mouthpieces. And we have, inside the mouthpiece, we have a particulate matter filter and a hygroscopic filter. So even if there's the sensors behavior responds differently at different temperatures and humidity, we also have humidity and temperature sensors in our device, so we also take that into account. And with respect to sterilization, most of these sensors work on the principle of absorption and desorption. So you give it enough time, like 5 minutes, or if you, in fact, add a heater, it could desorb in like 2 minutes. And I don't think it should really be a problem.
Can you talk about the accuracies of these biomarkers? Have there been studies done in the past?
Currently, the biomarkers, Dr. Anthony sir is working on one of the biomarkers. I asked them, so they currently have the biomarkers which calculates in millimole per liter, and they use hydrogens and other substances to give the reading. He even has a research paper published which is in the references. So yeah, they work.
Okay, judges, thank you very much. I appreciate it. Very